Okay, section 7.8, drawing scale diagrams. So we've been drawing some diagrams, but now we have to do them to scale. So we have to think about what scale is given and do the conversions and do some measuring. Okay, so Sanjeev is a builder. He plans to construct a patio at a community center. What are the dimensions of the patio in a 1 to 500 scale diagram? So basically, we know here in the diagram that the length is 12 meters. And so on our diagram, what will the length be? That's what we're trying to figure out. So it's going to be a lot smaller, right? And this says the scale is 1 to 500. So that means in real life, it's 500 times as big. So if we're converting back to a smaller, to the diagram, remember then we divide by 500 or multiply by 1 over 500. Okay, because this, obviously, this 12 meters has to be smaller. If we get it onto paper, we can't draw 12 meters long on paper. So same with the width, that'll be dividing by 500 or multiplying by 1 over 500. So 12 times 1 divided by 500. Oops, that was a plus, sorry. 12 times 1 divided by 500, 0.024. 9. You can just go divide by 500, it's faster. 0.018. That's in meters. So to convert from meters to centimeters, remember you multiply by 100. So it moves the decimal 2 to the right. So 2.4 centimeters, 1.8 centimeters. Okay. Next part kind of continues from that. It says Sanjeev needs a scale diagram for a newsletter about the community center. Draw a 1 to 500 scale diagram of the patio above. Record the dimensions on your diagram. So basically, that can be your scale diagram. So draw the same thing. Maybe I should try to use a straight edge at least. Or actually, I could do a rectangle here. Just give me a sec here. I want a rectangle. There we go. Okay, and so then just I would measure it out 2.4 centimeters. I can't do that when I'm on my computer like this, but you can get a ruler out and measure 2.4 and then compare to 1.8. So, and then label them. So this would be 2.4 centimeters and 1.8 centimeters. Okay, so they want an actual scale diagram, so you do need to use a ruler. Okay, example 1, Lizanne works for a plumbing company. She saw these specifications for a steel washer. So these are the actual dimensions of the washer. Draw a 2 to 1 scale diagram of the top, side, and front views of the washer. So we need to decide what our scale dimensions are going to be. Notice how this first number is bigger because that means we are expanding the real life. So real life is a lot smaller than this. It's 1/16. That's very small. And so that means if the first number is 2 and the second number is 1, then this actual washer, which is a lot smaller, is the scale factor from our diagram to actual. So a diagram to actual would be 1/2, right? So now if we're going from the actual to the diagram, we're going to multiply by 2 because we're trying to make it bigger. So what are the dimensions of the washer in the new scale diagram? So the width, we're going to multiply the width, which is 1/16 by 2, the inner diameter by 2, and the outer diameter by 2. So 2 times 1/16 is 1/8. 2 times 1/2 is 1. 2 times 3/4 is 3/2. Okay, so now on the next page, it says draw the scale diagram of the views. Okay, so what are which views? Top, side, and front. Okay, so the side is going to be, that's why they didn't say left side or right side, it's going to be the same. The side is actually going to look like just a vertical rectangle, right? The top, same with the top. And then the front, we'll use the front being this circle because that's typically what the front of the washer is. Okay, so again, you're going to need to get your ruler out to measure. So I'm not measuring, but I'm going to have front there, trying to make some nice circles. Oh, I'm going to have to move that. Okay, and so dimensions, so when we did our calculations, so the diameter 3/4 in real life ended up being 1.5 inches, 3/2. So this is going to be, this distance here is going to be 3/2 inches. So that's what you want to measure with a ruler. And then this would be from here to the bottom would be 3/2 inches. Okay, and then this diameter here would be 1 inch. Okay, so we'll call that the front. And then the side, basically like that. And then in top, maybe we'll do the top horizontally. Okay, and then the top. Showing these up. Okay, so then that would be 3/2 inches. And then remember that width of it is going to be 1/8 of an inch. Right, and then this is 3/2. And then this is 1/8 an inch, and this is the top. Okay, but use a ruler to measure it. Then a Rubik's Cube. Each side of the Rubik's Cube is 57 meters long. So this whole thing is 57, sorry, not meters, millimeters. Draw a 120% scale diagram of one of the smaller component cubes. So I don't know if you've ever taken apart a Rubik's Cube. You can actually click out the little cubes. So take out one of those cubes, okay, and then you're expanding it, making it bigger in your diagram, okay? So what are the actual dimensions of each smaller cube? So remember, it's 57 by 57, it's a cube, 57, so we're dividing by 3. So what is that? 19 millimeters. And so it's, the smaller cube is 19 by 19 by 19. Okay, what's 120%? Without the percent symbol, we divide by 100, it's 1.2. Okay, so we are, the scale factor of our new diagram is 1.2. but the ratio is 1.2 to 1. So it's a little bit interesting when you're asked for the scale factor. Depends what you're being asked for. So really they're asking for the scale factor of your diagram compared to real life, where sometimes they're asking for a scale factor of real life to the diagram. So it kind of depends. But here, scale factor of your diagram is 1.2. Now notice how the ratio there has a bigger number at the beginning, the first term, than the second one, because that means you're expanding from real life. Now, typically we don't show ratios with decimals, but when it's a scale, we like to have one of the terms being 1. So often we'll leave it as 1.2. You might see this somewhere though. If we get rid of that, that would be 12. If we multiply both sides by 10, 12 to 10, which is equal to 6 to 5. That's a proper ratio in lowest terms, but this is often how you'll see it because of that 1. Because you just want to measure 1 unit, whatever it is, when you're looking at a diagram, right? So what are the dimensions of the component cube in the scale diagram? So this is 19 millimeters is real life. So we need to multiply by 1.2. And so it's going to be the same all the way around. So 1.2 times 19 is 22.8. So 22.8 millimeters, 22.8, 22.8. Use the isometric dot paper, draw the scale diagram. So it's not telling us what measurement it's representing. Remember the diagonal, so your front view is going to be left diagonal. So basically it's going to meet the corner, is going to meet something like that. This would be the front, this would be the right. Now saying that, this is a cube, but we need to show it for 22.8 millimeters. So typically these are in half a centimeter or centimeter lengths. So if we went half a centimeter, so 5 millimeters, we would need to go, so 5, 10, 15, 20, 22.8, which is almost 23. So pretty close there. So 10, 20, a little bit more, about there. Same this way, so 5, 10, 15, 20, 22.8. And then 5, 10, 15, 20, 22.8. And then same all the way across. And then join, so it's right under. And then join that up there. So I'm just freehanding it. And then same along here. And then use a ruler, freehand that. Oh, I did it a little bit too low. I'm going to run out of space here. I'm going to extend it out. And that would be my cube. Okay. All right, so that's the end of that section. So do the practice on that. And then you'll see there's a 7.9 as well. And it says using technology. So I think they're going to want you to draw some diagrams on a computer. We're not going to do that here. Okay, so just do the practice. Then you can head to the chapter review. If you're doing this course in class, then perhaps you're going to go to the computer lab. So then you'll do 7.9. Okay, and then after 7.9, chapter review, chapter test. That's what you're assigned.